Okay, next thing we're going to do is we're going to try and work it out in y equals ax squared plus bx plus c. Okay, so c is always your constant value. So if your graph passes through your y-axis, then that is a coordinate that you're going to use. So the first coordinate you would state would be the one where x is 0 and y is equal to another value. Okay, because that's going to be the easiest one to solve for. That's going to give you that value on the end straight away. But for me, I don't have that. So I'm going to be using the coordinate of 1.5, 17. I'm going to choose to use the one near my turning point as well, 13.5 and 8. And I'm going to choose to use the one on the end. Okay, so we're going to try and keep this in exact form for as long as possible, just because it's going to make it less messy when we put it in 2 Desmos, because we're not going to have as many rounding errors. Every time you have rounding errors, especially when you're dealing with values as small as this, it's going to make it harder for you to get an approximate answer that's correct. Okay, so what I've got here is I've got an x coordinate and a y coordinate. I'm going to start by substituting these back into my equation and seeing what I'm left with. So 17 equals a 1.5 squared plus b 1.5 squared, 1.5 plus c. So I'm going to rearrange this so it's in the form of c equals, because then I'm only looking to get 2 different values. Okay, so now I've got 1.5 squared is equal to 2.25. So I've got 17 is equal to 2.25a plus 1.5b plus c. And I'm going to move the a and the b to the other side by making them both negative. So whatever the symbols was there, I'm taking them to the other side. That's going to leave me with c equals 17 minus 2.25a plus 1. Oops, sorry, not plus. Minus 1.5b. Okay, now I'm going to use this as my c value, and I'm going to substitute this one in as x and this one in as y into the equation again, but instead of having c, I'm going to use this. Okay, so now 8 equals a times, what is it, 13.5 plus b, that should be squared, plus 13.5 plus, now this is my c value now. So 17, I'm going to put a bracket around this, minus 2.25a minus 1.5b. So first step is to simplify this expression, and then I'm going to group my like terms and rearrange it so it's in the form of a equals or b equals. That way, when I do this again for the last set of coordinates, I will only be solving for one unknown variable. Because the problem is I've got a, b, and c. 3 coordinates means I need 3 different values to fill in these variables. Okay, so 8 equals 13.5 squared, that's a big number, is 182.25a. I'm going to write this one next to it. So minus 2.25a is going to give me 180a. Okay, and then the next one, so I've got plus 13.5b minus 1.5b is going to give me a value of plus 12b. Then my constant is going to be plus 17. Okay, so now I'm going to rearrange. It doesn't matter whether you go for A or B next. I'm going to take the 17 across first by subtracting 17. 8 minus 17 is going to give me negative 9. Where's my little pen gonna? Okay. Negative 9. 180a plus 12b. Then I'm going to take the 180 across, the 180A across. Like I said, no particular reason. You could do it in any order. So now I've got, okay, -9 minus 180A equals 12B, and then I'm going to divide this side by 12. So now I've got B equals -9 minus 180A, all divided by 12. And if I put this in the calculator, it would simplify it further. So let's do that next step. So obviously I can't put the A in the calculator. Actually, maybe we'll just leave it there. Okay, so next thing that we're going to do is I'm going to use this as B, and I'm going to put it back in up here. Actually, where am I going to put this? Okay, we're going to do this again. But what am I substituting in where? Now, this is much easier when you have one piece of paper that you can see all you're working on. Okay, so I'm going to start doing some working on this side. Where did my question actually start? Okay, so let's state what we got. So C equals 17 minus 2.25A minus 1.5B. Okay, we substituted that in there and we worked out that B is equal to -9 minus 180A, all divided by 12. So I'm going to take this and I'm going to substitute it back up in there. So now it's all in terms of A. So C equals 17 minus 2.25A minus 1.5. Now, I'm going to write this as separate terms when I do so that I can expand my brackets and simplify what I've got. Okay, so C actually equals 17 minus 2.25A. Okay, then I'm going to do minus 1.5 times -9 divided by 12. Execute. So that's going to give me plus 1.125. Then I'm going to do negative 180 divided by 12 times that answer by negative 1.5, which gives me plus 22.5A. Okay, and now I'm going to group my like terms. So this one and this one will get simplified to be C equals 18.125. This one plus this one is going to give me plus 20.25A. Okay, so now we're ready to substitute C in terms of A. We've got B in terms of A, which means now I've got an equation that can be solved because we've got our one unknown of A, and then we're going to substitute everything else back in for C, for B. Okay, so now, let's look for that coordinate again. So it was 30 and 19.5. So now 30, 19.5. So y equals 19.5 equals A 30 squared plus B 30 plus C. And I'm going to substitute C in and I'm going to substitute B in. So 19.5 equals, now 30 squared is 900, so 900A plus 30 times, now where's our expression for B? minus 9 over 12 minus 180 a over 12 bracket plus c is 18.125 plus 20.25a. Okay. So I'm going to expand the brackets and group my like terms. 19.5 equals 900a plus, now 30 times negative 9 is negative 270 divided by 12 is going to be negative 22.5 minus, now I'm going to do 30 times negative 180 divided by 12. So minus 450a plus 18.125 plus 20.25a. Okay, now we're up to grouping our like terms. So all of the a's, I've got this one and this one and this one. Don't forget to take the symbols in front. So 900 minus 450 plus 20.25. Okay, so 470.25a. Okay, and now we're going to group our ones. So now we've got this one and we've got this one. So minus 22.5 plus 18.125 minus 4.375. And now I can take this to the other side by adding 4.375, which leaves me with okay, zoom down to give myself some space. Okay, so my A value is going to be 23.875. It's equal to 470.25a, and you're going to divide this side by 470.25 to get this away. So now I've got A is equal to, pop that in the calculator. Now, when I put that in Desmos, I would leave it like that so that I have a nice exact number. Because when I put this in the calculator, it's not going to like it. Oh, my A value is going to be 0.0507. And I'll leave it there. Okay, so now I can take this as my A value and I'm going to substitute it back in to find B. So B was equal to negative 9 over 12 minus 180 over 12a, and I'm using this a up here. So that's equal to negative 9 over 12 minus 180 over 12 bracket 23.875 divided by 470.25. And pop that in the calculator. Okay, so now B is going to be equal to negative 1.511. I'm going to round that to 6, so it's 2, 4, 5. So this one should have been 8. So I'm rounding to 4 decimal places each time. Okay, so I can't get this to give me a nice number in the calculator. It's probably a really long fraction. So I'm going to stick with this value. So now when I find C, I'm still going to be using A, so it'll be okay. So when I'm substituting in to find C, C is equal to 18.125 plus 20.25A. So I'm going to substitute A into that. Punch it in the calculator, get my answer. So again, I'm using the fraction so that I don't have any rounding errors, because the rounding errors in this will make a large effect because the numbers are so tiny. So I'm punching that in the calculator now. Okay, so C is equal to 19.15. Now, if you did have a y-intercept, there's going to be a lot less working for you because you can let x equal 0 and then you find C straight away. So that means you cut out a whole heap of working. You only have to solve for 2 different variables opposed to 3. The last step is to state what equation you found, because what we found is that C equals this, B equals this, and A equals that. So y equals 0.0508 x squared plus negative 1.5116 x plus 19.15. And if I'm going to 4 decimal places like the other ones did, it'll be 26, because the numbers after this are 256, means that 5 will round up. Okay, and that's the final equation that I found. Now, the next step that I need to do is to test this in Desmos. Test this in Desmos by graphing it against the other quadratic equation that it generated for me. The one that it generates should give you a better r² value because it doesn't get rounding errors, whereas you have little rounding errors in here. Okay.